Hi, I'm Badal from Team 11. So our final project proposal is predicting heart disease. So our main objective is to predict whether uh, your human, whether a person is prone to heart disease or not based on whatever the inputs he give. So what our main objective here is once we predict the probability of whether the person is prone to heart disease, we'll also show them the important factors that is leading that disease and with respect to their inputs, and also tell them that this is areas where you need to focus so that you would improve your health eventually. So coming to the flow of our project. So what we have done is we have had model as a service where we take data as CSVs and then we perform some feature selections on that. Once we do it, we do the modeling and then we get predictions and put it into the streamlet. So the data we took is key indicators of a heart disease. So the data is from a website called CDC, and so this data is updated on an yearly basis. So we have taken the updated 2021 data set from CDC. So the whole process is through the Airflow. We use Airflow DAGs to scrape the data and then transform the data into the S3 bucket, and then we perform some operations. So once we have it and we clean the data, we also run the great expectations on it to validate the data. So this data, which is ready in the S3 bucket, is then consumed for our EDA and feature engineering. So in the initial step of the modeling part, we have done uh, data analysis and also feature selections and feature engineering. So once we get the selected features, we then performed modeling. So once we have this model ready, we also may perform model interpretability, where the model gives us the important features that is causing us to get the target variable. And so this model is then stored as a pickle file so that it is ready to use in our Streamlit application. So whenever an user gives us inputs, we hit this model and then give the outputs and push it to the Streamlit. So all this process is in the form of an API, as this fast API, and we have hosted it in EC2. So this whole communication is through the front end in Streamlit, and all these user activities are logged in CloudWatch, so that when we also have a user registration and login page. So whenever a user logs in or registers, all these activities are logged in the CloudWatch, and we also scrape this CloudWatch data to see whether a user is already present or not, so that he could create a new account. So this is about the architecture. And coming to the application, um, as soon as we land on the page, we see a registration page. So I'm creating a login. So we have all the validations for filling this form. So it says, please enter the password if it's empty. And it also gives me, it says password do not match because it's empty. And even if I type something, it says that the password should have all these fields so that we don't have a simple passwords for the user to register. So as soon as I give the credentials, I'll be able to log into the user page. So if I give a wrong password, it would tell me that the user does not exist. And after validation, it says that the user logged in and successful credentials. So when I go to the home page, I'll be landing on a page where we mention that what Pulse Vision is, and so our app name is Pulse Vision, and we wanted to let the user understand like what happens inside the application. And when we move to the prediction heart health part, so as soon as we enter into this page, you will see a lot of fields where the user can input. let's say I choose some fields where a female of age 32, 34, she's an Asian, she doesn't smoke or drink, but then her BMI is based, her health is fair, and she's not a diabetic nor an asthma patient, and not having a stroke before, nor a skin cancer, nor a kidney disease. So these two fields which you see here are the optional fields. So whenever a user selects that their health condition is good or fair. So what health condition means is that, let's say a person in general, how do they feel on a daily basis? So here, let's say if the person selects fair or poor, only then these two fields will be shown. If a person says that the health condition is good, these two fields will be not shown. So there is a reason for us to give these two as an extra fields, which we can cover up later. So for now, she's feeling fair and her food habits are a balanced diet and she doesn't exercise. So once we click the button to predict the heart disease, we trigger the API that is hosted, and also it would say that you are healthy because the heart disease prediction is 18%. So if we go down a bit, we would be able to see like what are the factors that are causing the heart disease here. And also for a person to select these inputs to help them in more detail. Let's say if the person doesn't know how to calculate the BMI or which class they belong to, we can go to this BMI calculator and then check, like, let's say if it is a 59, if the person is 59 kg and 160 centimeter of height, we would say that he's of normal age. And also let's say we can select like normal weight, and let's say they drink alcohol or of a different age. So you could see the changes in the prediction, that the prediction would raise to 76%. So moving forward with the interpretability, let's once we hit this button, we get the predictions from the model that hits through the API, and then this percentage is the probability of a person being prone to heart disease. So as soon as we get the result, we also get the interpretations from the model. So we are using SHAP analysis here. What SHAP tells us is clearly whether a person is prone to, like what percentage uh, of the probability he's prone, and also what are the factors that are leading to this prediction. If you see here on the one on the red are the features that are causing this percentage, and the one on the blue are the features that are decreasing this percentage. Like let's say if the general health is uh, like poor, then there are chances, then we actually encode this general health to different classes based on if it's poor or whether they are good in health or whether they are very good in health. So if now the class is fair, so let's say if the general health is high, like if the general health is like very good, there are chances that this percentage might reduce because they are more healthier. So this clearly mentioned the order of the contribution as well as the features which are separately contributing to this percentage. So like you can see here, the reason for getting 76% is the most important thing is the stroke. I think we have given that, yeah, the person has a stroke before, and also their general health is poor, and also they are diabetic. So these three are the factors that are like increasing the impact of a heart disease. These are the features among all the features we are considering. So if you see on the blue color, it says that the person's BMI is good and also they are alcoholic. So this is an interesting insight because if you could see here, the BMI is making sense that it is reducing the prediction. But then the reason for having an alcohol is there were studies that alcoholic like having an alcoholic habit for to some extent or drinking occasionally is having an healthy effect on the heart because it reduces some bad cholesterols and gives good blood circulation. So that is the reason it says that alcohol is a factor for not having a heart disease. So to some extent. And also, we could see each feature, like to what extent or what contribution they're having in the prediction. If you see, the stroke is contributing to 27% in the prediction, and the general health is 21%. And since they're diabetic, it's contributing for 9%. Similarly, we also mentioned the factors that are reducing the reasons for the rest of the 24% for not causing the heart disease. So after this, we also mentioned these three factors here, stating that these are the factors that are in your control and you could do something to get things better. Let's say if a person, so there are also some studies that white persons or or males are more prone to heart disease. So these are actually, it depends on different factors. Let's say if these are all are very normal and if a person is in male and white, there are chances that we would get the predictions that since you're a male, that is also a reason for heart disease. So that is just a fact. It doesn't mean that every male can be prone to heart disease, but based on the studies, that would be a factor for causing the slightest percentage of uh, uh, that can lead us to heart disease. So let's say if the factor is a male or a race, that he's an Asian or a white person, we can't do anything about it. We can't change that. So we don't mention if even that comes under the factor that causes the heart disease. So we only mention here the factors that are under human control and they can work for it. So once we get all these three important factors, we tell the user that if you wanted to improve, you could just click on this expanders and then see what you can do. These are like the basic things everybody can do to just reduce the risk of heart disease. Like if they to improve the general health, they can do all this, like have a healthy diet and all. So these outputs we get are using an Q&A OpenAI APIs. So Q&A OpenAI API can answer all the general questions. So since we are not answering in a doctor perspective, we just wanted to give a general idea to the user. So we thought it would be efficient and nice if we use the OpenAI's Q&A API. So based on, let's say if the general health is in the top list of top which needs to be taken care, so like I mentioned here, we consume these inputs. Now that we know that the user is having a lot of junk and but then they exercise regularly, we take these inputs and give to the Q&A API as a prompt so that we get more specific response from the Q&A API. So it's user specific. It's not like a generic one. Let's say if the user says that he doesn't exercise and he eats a fiber rich food or something, then we might get a little different answers that, yeah, it says that you have to limit some saturated fats or something like that. So these are like a little specific, user specific answers we could do using prompt engineering. So we thought that would be an add-on to get these outputs. And also if you say stroke, it would say that follow balanced diet and also go to regular checkups. And if a diabetic, it will say that it is a risk factor for heart disease because of the blood sugar levels, and then changing your lifestyles and exercises, maintaining. So all these like generic answers it would give us just to make sure that the user is aware of all these precautions. So this is about the local interpretability. Coming to the insights. So this is actually the global interpretation. So the we got this interpretation on 13,000 records of previous key indicators of heart disease. So once we got the model, we used SHAP to get this interpretation. So here the insights say that in general, the age category is the one that affects more on the heart disease. Like if you see the one on the red means that the people are highly prone to heart disease. So the one on the blue is that the lower the age category, lower the chances of getting a heart disease. So that's how the color difference helps us understand. And all the order here is based on the order of the contribution to the impact of heart disease. Like the most important factor is age, and the least important factor is alcohol. So in general health, let's say if the general health is low, it means that if it's poor or if it's fair health, there are chances that they might get heart disease. So that's why it's red in here. If the general health is good, the high chances that they won't get heart disease. So according to the studies, there is a study that males are more prone to heart disease. So that's why you could see if E's male is 1, which is actually the male category, then we would see that they are prone to heart disease. The same thing for stroke. The more the stroke, like if they have a heart stroke before, obviously they're more prone to heart diseases. Similarly, the diabetes, smoking, and also kidney diseases causes the effect. And also if you see the alcohol, the interesting fact is that the one who doesn't drink at all are having a high chances of heart disease, but not the one who drinks or moderately drinks. So here, on a condition that it's not applicable to everyone, but there were some studies that having a little alcohol in a little volume is definitely good for health with some scientific reasons. So, but however, if the age category is too high and they're still alcoholic, so it's vice versa. They are going to have the high probability of heart diseases. So it's totally basis on different factors. So each factor is dependent on the other, and also, but in general, different factors have different effects on prediction of this heart disease. So this graph like simply explains all of this in one go, and we have clearly like mentioned everything for the user to read it here. And so this is all about the application. We have the BMI calculator insights and predicting the heart disease, and the user login and registration page. So whenever the user is done like using the application, if he clicks the logout button, he will be able to again come back to the registration of the login page and then access the application. So all these user activities are being logged in CloudWatch. Like if you could see, we have registration and login logs. Like we're registered right now for the demo. You could see that the demo log is already here. And in the same way, so once we have all these logs, so whenever a user registers and then goes to the login, when clicking this button, we extract all these logs from the register logs and then see, okay, whether the user registered or not. If yes, only then login. And then we match the passwords with the hashed passwords here so that we authenticate it without any security breaches. So this is all about the application, and we have included all the code and architecture diagram, and everything is posted in our Git, and also the app is hosted on EC2 instance. And we have submitted all the other documentations required. Thank you.